If you remember, when we did the lesson on rotation, we discussed how we rotate an object on a grid. And we decided that there were some rules about that, how you described it. There were three things that you had to be able to note to help describe fully the rotation. The first of these was, where's the center of the rotation? Now in the case of this diagram, the blue dot indicates where we're going to rotate it about. It's at x equals 1, y equals 1. The second thing you needed to be able to describe was how much you turned the object through, what sort of angle. Was it 45 degrees, 90 degrees, or something like 180 degrees? So for example, in this case, 90 degrees. And the third thing you need to be able to do to describe fully the rotation was, which way did you rotate? Did you rotate it clockwise, or did you rotate it anti-clockwise, as in this case here? You could use tracing paper to help you with this. In fact, it's easier with tracing paper, and normally tracing paper is provided in exam conditions. Let's take a little example of this. We're going to rotate this object you see on the right hand side, and we're going to turn it through a quarter of a turn clockwise, and we're going to use the center point 0, 1, x is 0, y equals 1. It's marked with the red cross on the screen. First we're going to place our tracing paper over the area that includes the shape we want to rotate and the point of rotation. Secondly, we're going to trace the shape out on the tracing paper. Thirdly, we're going to put our pencil on the center point, the bit we're going to rotate around, 0, 1, and then we're going to rotate the tracing paper, in this case through a quarter of a turn, through 90 degrees. Last but not least, we'll now trace out the object that we've already drawn before onto the tracing paper to show where it finishes. And now we've actually finished rotating the object 90 degrees clockwise about the point 0, 1. Now what would happen if we used a different place, a different point as our center of rotation? What we could do is experiment with this particular setup, and we can move the cross, the red cross there where the center of location is, around the grid to see where the object would finish up if we were to rotate it 90 degrees clockwise but around a different center of rotation. So I'm going to move the center of rotation up, just up one grid there. So it's x equals 0, y equals 2, and you can see where the object's now finished up. If I move it down to 0, there's the impact of that. If I move it to the left, I'll move it 2 to the left there. Well, you can experiment with that on Mymaths as you wish, but you can see what the impact is going to be. Going back to our original problem, I just want you to imagine for a minute that we could draw a sort of bracket from the point of rotation to the object and make it into an L shape like this. And then we're going to imagine that whole bracket, this L-shaped bracket, rotating 90 degrees so it finishes up like this. So it's going to finish up like this here. You'll notice that the distance the original bracket was away was 2 units, and now it's 90 degrees, 2 units going vertically instead of 2 units horizontally. Another point to note is that if you draw a line along the base of this particular object until it hits the point of rotation, and do the same for the one now that's been rotated along its original base until it hits this point here, these two lines are at right angles to each other and go through the same point of rotation. Here are various shapes that we want to transform. I'm going to take an example of rotating shape A onto shape H. So let's first of all then highlight shape A. There we go. Now to do that, if we think about it very carefully and look at the diagram, we can see that we're probably going to have to get it onto H, we're going to have to rotate it through 90 degrees. Just move that over there to see if it fits on top. You see it fits exactly on top if you rotate it 90 degrees. But we've got to rotate it about an origin that we haven't worked out yet. We can probably guess that the point of origin is going to be below this common point, this point here and this point here. It's going to be somewhere down in this region to rotate it around to get it back to where we want it here. So what we'll do is we'll put some tracing paper down and we'll draw the shape onto the tracing paper, and then we'll guess where we think the point of origin is. And I'm going to guess it's somewhere around here. It's probably going to be on the cross between a vertical and horizontal line where they intersect. I'm going to draw now a line between that, what I guess is the origin, and the shape, like this. I've connected a line from where I think it's rotating to the object and given the object the same color. And if it works, I can rotate now my tracing paper to see if I can get this image to land on this target image here. Let's have a look. We'll rotate the tracing paper once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and 8 times, and it seems to fit perfectly, doesn't it? Now I can tell if it really has fitted perfectly, if this is correct, by checking to see if these intersecting lines here, these 2 yellow intersecting lines, have a right angle, and they do. Because of course the whole thing's been rotated 90 degrees. This line here is 90 degrees away from that line there. So I have found the point of origin, which in this case is x is minus 1, so it's minus 1 from the origin, and y is 0 because it's sitting on the 0 line. It's not 1 or minus 1, it's sitting on this line here, 0. So the answer is going to be minus 1, 0 for that origin. And that's it really. Simply using a pencil, a piece of tracing paper, and drawing the object onto the tracing paper, guessing where you think the origin is, and then rotating the image to see if it lands on the target image. Let's take another example now where we want to rotate the shape K onto the shape J. So we want to get K rotated so it fits into the same shape as J. Well, if you just saw that again, watch once more, we're rotating it clockwise and we rotate it at 90 degrees. So where is the point of origin? About which point are we rotating it? Well, because these 2 shapes touch, we can probably guess that the point of origin is at the point where they actually touch. So we'll have a guess that the point of origin is here at minus 4, minus 3. Now what we do again is we take the shape K and we draw it onto our graph paper, and we'd start rotating the graph paper to see if it will fit directly onto J, and as you see it does. So this is a very, very straightforward one. Where the 2 objects actually touch, that's usually the point of origin. That'll be the same over here for F rotating onto D. It would be clockwise 90 degrees and the point of origin would be here at 4, x is 4, minus 3, y is minus 3. Okay, let's try something slightly different where we have to rotate something by 180 degrees. I'm going to take the object over here, B, and I'm going to rotate that to get it onto the object F, sit literally on top. I'm going to have to rotate it around 180 degrees and get it to sit one on top of the other like that. So where would be the point of origin for this? Well, we can guess that the point of origin is going to be somewhere between the 2, since it's 180 degrees. Maybe somewhere along this line, halfway from B and halfway from F. To really work it out exactly right, we'll draw a line between the 2 points, the 2 common points for the shapes. So when I rotate B round to F, this point will be this point, and I draw a line between the two. And where you see halfway along that point, this point here looks like it might be the point of origin. So I'm going to guess that's the point of origin. So again, what I'll do is I'll draw the object B onto my graph paper, my tracing paper, and I will then use this point here with my pencil to rotate the shape. So I'm going to rotate it round clockwise, but I could do it anti-clockwise because it's 180 degrees to see if it'll line up perfectly with the shape F, and it does. So it does look as if this is my point of origin, and that point of origin is 5 along the x-axis and -2 on the y-axis. So it's 5 minus 2. Anything else you see on here in terms of rotating shapes is a variation of what we've just gone through. Just using your tracing paper, your pencil, and doing a bit of rotation, trial and error to find out the origin, although there's usually some clue as to where the origin actually is.